Hi, my name is Zakrzewski, and today I'm going to talk to you about my work entitled The Interplay of Photopolymerization and Phase Separation Kinetics in 3D Printing using PPG and methacrylated PPG. So starting with our materials, essentially these are the monomers, photoinitiator, and polymer additives that we used in this study. Our neat resin is comprised of these two monomers on top, PETA and 2-EHMA, and our photoinitiator, TPO. And specifically, we are holding that in a 3-to-1 weight percentage mixture of PETA to 2-EHMA with 0.58% of TPO. Then some samples also included these polymer additives, specifically PPG at these various molecular weights and PPGMA at this 1 molecular weight. And for all those samples, they were held at 15 weight percentage. So now moving forward, I'm going to introduce our custom-built UV transmittance apparatus, which we use to detect our phase separation occurring in these systems. So if you look on the left there, you can see that we have these 3D printed pieces that hold everything in place. Our UV LED light source on top, our detector on bottom, and our sample in the middle there, which is sandwiched between a glass slide and a cover slip with a spacer in between to allow for a uniform thickness of sample. This essentially will allow us to irradiate our sample with UV light, which will essentially start our photopolymerization. As the photopolymerization continues, the concentration of our photoinitiator will decrease and our transmittance will go up. Another thing to note is that if our sample has phase separation, turbidity will go up and transmittance will decrease. So now moving forward to our first data here, remembering that we have this resin comprised of these two monomers on the left in a 3-to-1 ratio and 0.5 weight percent of TPO. We also have these polymer additives that we're adding in here, which is PPG at the various molecular weights and PPGMA at 1 molecular weight with 15% concentration. So now looking here, we can see that neat resin, PPGMA, and PPG425 all do not have a decrease in transmittance, but they do have a slight increase over time as the TPO is being consumed. However, as we increase the molecular weight of the PPG additive, we can see that the extent of phase separation becomes more drastic, which shows us that there is a molecular weight dependence on the phase separation ability of the polymer additive in the resin. So now moving forward, that same plot that I just showed is in the left right here, and the next two are the same sort of plot but at a higher UV intensity, and we can see the same trends are visible. However, there's something else that we can notice here. So as you go from left to right, or as you increase that UV intensity, the extent of how far this dip in transmittance goes decreases. So essentially, the extent of phase separation is decreasing with an increased UV intensity. And we expect this to happen because at a higher UV intensity, you have more photons being irradiated into the sample. So we have more photopolymerization happening at a faster rate, and these polymer additive molecules are essentially getting entrapped in the quickly developing polymer network, and they're not able to phase separate out as efficiently. So now moving forward, we can see that still holds true if we look at one specific molecular weight. On the left here, we have PPG 2000 at the lowest UV intensity. We have the greatest extent of phase separation, and at the highest UV intensity, we have the lowest extent of phase separation, which is what I just mentioned on the previous slide, and we can see that it holds true as well with PPG 4000. Another thing to note is that these triangles here are denoting the induction time for photopolymerization, and as you increase the UV intensity, the induction time of photopolymerization as well as phase separation becomes quicker. So then to conclude, again, we made this neat resin comprised of a 3-to-1 mixture of PETA to 2-EHMA with 0.5 weight percent of TPO photoinitiator, and to that neat resin we added various polymer additives at various molecular weights at a weight percentage of 15% concentration. We also used a custom-built UV light transmittance apparatus, which provided a uniform UV intensity profile to irradiate our samples with UV light and essentially start our photopolymerization. We were able to conclude several things. Firstly, being that as the molecular weight of PPG increased, the phase separation in the system became more predominant at all UV intensities. And then lastly, as the UV intensity increased itself, the extent of phase separation decreased as the polymer additive molecules that were in the system became entrapped in that quickly developing polymer network. Thank you for your time, and thank you for listening.